Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the specific heat. We know from experience that it takes different amounts of energy to raise the temperature of identical masses of different substances by 1 degree. For example, we need about 4.5 kilojoules of energy to raise the temperature of 1 kilogram of iron from 20 to 30 degrees centigrade, whereas it takes about 9 times this much energy to raise the temperature of 1 kilogram of liquid water by the same amount. Therefore, it is useful to have a property that will enable us to compare the energy storage capabilities of various substances. This property is the specific heat. The specific heat is defined as the energy required to raise the temperature of a unit mass of a substance by 1 degree in a specific process of frictionless internal equilibrium without phase change and chemical reactions. Specific heat not only varies with different substances and different processes, but also depends on the state of the substance. The specific heat of 1 mole substance is called the molar specific heat, Cm, kilojoule over mole Kelvin. The specific heat of 1 standard cubic meter substance is called the volume specific heat, C apostrophe, kilojoules over standard cubic meter Kelvin. The relations of these specific heats is: I have one question for you. Is the specific heat a state quantity or a process quantity? Let's look at the two processes in the TS diagram. C1 and C2 are two specific heats. They are different and they depend on the process. For a specified process, the specific heat is state quantity. Two mostly used specific heats for specific process: specific heat and constant volume, and specific heat and constant pressure. Physically, the specific heat and constant volume, Cv, can be viewed as the energy requirement to raise the temperature of the unit mass of a substance by 1 degree as the volume is maintained constant. The energy required to do the same as the pressure is maintained constant is the specific heat and constant pressure, Cp. This is illustrated in the figure. The specific heat and constant pressure is always greater than Cv because at constant pressure the system is allowed to expand, and the energy for this expansion work must also be supplied to the system. By definition, the specific heat and constant volume is. Recall the first law, which can be expressed as: for the constant volume process, the first law then is. The expression for the specific heat and constant volume then is equation 414. By definition, the specific heat and constant pressure is. Similarly, an expression for the specific heat and constant pressure, Cp, can be obtained by considering a constant pressure expansion or compression process. It yields equation 415. There are some comments about Cv and Cp. Note that Cv and Cp are expressed in terms of other properties. Thus, they must be properties themselves. Like any other property, the specific heat of a substance depends on the state that, in general, is specified by two independent intensive properties. That is, the energy required to raise the temperature of a substance by 1 degree is different at different temperatures and pressures. 1. Cv or Cp is for a determined process, and then it is a state quantity or a property. 2. The above derivations do not employ the ideal gas equation of state. Therefore, the expressions are valid for any substance undergoing any process. 3. Calculations of H, U, and S require Cv and Cp. Okay, that's all for this task. Thank you very much, and see you next time.